All right, so we're about to run a scan on an entire file system from an embedded device, and we're going to be looking at PHP files in order to find possible command injections. Are you ready? We're done. So that took 1 second, 1.5 seconds. It generated 4 alerts. It analyzed 178 PHP files, and it found locations where we can potentially inject into. We know that we can actually inject into these because there are CVEs for it on the full disclosure mailing list. Now, previously, we had a video that dealt with code analysis, source code analysis. And on this video, we talked about using something called drec to use regular expressions to parse source code and, well, not parse, but to look for patterns in source code and then take that and display it in a really nice interface that allows us to mark them as okay, a warning, or critical, and type some notes about them. This lets us keep our POIs, or points of interest, nice and organized. It allows us to work on a team if we pass this file back and forth. There's really nice things that we can do with this. But one of the things that we mentioned is that you can't parse languages with regular expressions because the languages typically that we parse, like PHP, for example, are not regular languages. So what we can do is actually takes a parser, something that will take a stream of text or source code as input, lex it, parse it out into a structure that has semantic meaning behind it. Usually this is a syntax tree, or usually syntax trees have lots of like sort of detail in them about where tokens start and where they end, line numbers, and things that are specific to that parser. And when you remove a lot of those very specific things to make it more general or abstract, then it becomes an abstract syntax tree. So what we're going to do is we're going to use a parser generator called TreeSitter, which is developed by GitHub and maintained by GitHub. It has bindings for a bunch of different languages. We're going to use the Python binding, and it has a whole bunch of parsers that are supported. The parser that we're going to use is for PHP. If we head over to tree-sitter.github.io, you can find all the information you want about TreeSitter. Right now, we're just going to actually start walking the tree that comes back from after parsing this. And once we get to certain areas like function calls, and those function calls have parameters, we're going to check to see if the function that we're calling is one that could be injected into to cause command injection, things like system and exec. And we're going to be looking at the arguments that are passed and see if any of those start with like a $_ get or request or something like that that may indicate user data being passed in. And we'll kind of discuss some other things that we can do with this too. So now going back to the original scan that we did, we ran it across an entire file system. It went through and tried to find anything with a .php extension and just assumed that was PHP. If it doesn't have that extension, it's not going to analyze it. So you might have to consider that if you're trying to use this code base. Sometimes PHP will be labeled as like .cgi or PHP5 or something like that, right? So just something to think about. So the type of an alert that we have here is this. So it says possible command injection on line 12, 13, and another one on line 12. What we can do in this line 12, these are actually from different files. So it looks like a double alert, but it's not. I will click on this one. Let's do the NA one. So board data NA, it tells us here, essentially what's going to happen is there's going to be a query parameter that we can get called MAC address. That's going to be fed to this binary on a system that this came from. So this came from like a random Netgear firmware that I knew from looking at the full disclosure mailing list was vulnerable. So the CVE here talks about some of these things. Board data NA PHP has an cause a command injection on a unauthenticated endpoint, right? So there's nothing during our analysis that's going to say like, oh, this is unauthenticated. It's just going to show us that the potential is there, and we have to go find that stuff ourselves. So it's not going to do everything for us, but it's going to locate some really interesting POIs, right? And this is something that you can write once and run every single time that you do this type of analysis. When we looked at the original drec, where we were just looking for regular expressions, what ended up happening is we had 1,700 different things come back. Now, that's a little unfair because there were things like iframe and input, things that I didn't really care about. I was really looking for command injection. So we can tone all that stuff down, and all of a sudden our list will get a lot smaller. But with parsing, we can be a lot more specific and make sure that the semantics behind what we're analyzing is really true and not just a comment in source or misinterpreted as a different type than what we're really looking for. So the CVE on this, we go to CVE details. It tells us there's a Metasploit module. We can go to that Metasploit module, and this will tell us more information about it. It does say board data www, MAC address. So these are the things that we want to look for. Sorry, not board data www, board data www. And our scanner actually found this, which is really cool, right? One of the things I do want to note before we go on is I have a couple of smoke tests in here to run the analyzer against in case you wanted to play with this. The first one, let's run it on the second one. Everything is safe. Let's run it on the first one, finds an issue. And then Windows Defender actually alerts and tells us that a threat was found. It tells us that it's a backdoor. Yeah, which is weird. So it is the actual PHP file that's alerting. And literally all it is this. So I'm going to delete this from the smoke test, but I did put a note inside of the README file. This is not a virus, okay? All right, so we'll remove that. I'll go ahead and rename this to 1, and then I'll just push this code as a sample smoke test. So the code that we're looking at right now and we're running analysis on, again, comes from that file system from Netgear device. Now, all I have to do from this point on in other engagements or things that I'm looking at is just run this to get this output. So what we're going to do is kind of go through what TreeSitter does and get a little bit of an understanding of how this works. To do that, I really want to talk a little bit about the build process and what we're doing when we're approaching or working with a parser generator, because it is something that's a little bit different if you haven't done it before. So I'm going to go into my command palette on this. We're going to get a little preview of the README. None of this is committed to GitHub yet. All right, so this kind of like toy analyzer built on TreeSitter, which only contains a PHP analyzer, which only looks for a very specific case, right? So this has to be built out. And I think I would build this or architect this a much different way if I wanted to include different languages. But essentially what you do is you'll run Lazy Bloodhound. You'll give it a location of either a single PHP file or a directory, and then it'll glob that up and start walking that directory structure, looking for PHP or .php files to analyze. There's a couple of things that we can add to it as a command line switch for verbosity. So if we go back and analyze real quick our our simple case, if I do -debug, there are some things where like it'll spit out unhandled nodes. So things that I haven't explicitly tried to check for, that might be kind of not included in analysis. I've tried to include that so that it pops out and you can go and implement it. In verbosity, it tells us a little bit of information about what we're analyzing. So if I go over here and we take a look at some of the output lines, like it says line 105. If I go all the way down here, there's actually 120 lines. So what happened? Well, this is all HTML down here, and on line 105 is the last element of PHP, and it was able to pull that out. So even though you have PHP and HTML kind of intertwined in this, that's no problem for TreeSitter. It'll be able to parse that stuff out and pull it out and let you know exactly where the line number is. It's not going to get confused or, kind of off balance on this stuff, right? So it'll be true when it tells you a line number. So other things too is we'll have these like variable assignments. So anytime a variable is assigned, we'll kind of mark that and put it into a symbol table. And then anytime a function is hit, what we're going to do is print out some information about it. So for this example, there was a variable assignment on line 16. And if we go up to line 16, it tells us that message update success is what it comes out as. Now check this out. If I go ahead and run this without this, there is a print symbol table function. And in the main function here, I have commented this out, but you can run this and it'll show us what our symbol table is. So What's neat about this is every time that a variable is assigned, it'll print out some information. So if we look here, flag is actually assigned and reassigned multiple times, okay? So flag on line 6 in PHP 1 gets set to false. On line 17, it gets set to true. And then again on line 23, it's going to be set to true. And then on line 26, it'll be set to true again. This is really cool when you're trying to just quickly evaluate some variables and how they might be reassigned. So for example, this is a string value. Message was actually originally initialized as an empty string here, and then down further, it's added or it's updated to update success. So what we'll do is go back and take a look at the kind of structure of building this, okay? Okay, so the installation process, we're essentially just installing treesitter with pip3. Then we're going to clone this repo. We're going to jump into, if it did that, to lazy bloodhound, see the parsers directory. So this will be lazy bloodhound parsers. And then we're going to clone treesitter PHP, which is the actual language, the parser for this. So once we get that parser downloaded, and again, there's a ton of these parsers available. So if you're interested in analyzing a different language using these methods, what you can do is take a look at what you're interested in. So if you want to look at Bash scripts or JavaScript or Java, you can grab those languages, right, for that parser. So once we have that taken care of, we can clone this, go back, and then we'll run this build script. This build script is essentially just going to use their mechanism for building essentially a shared object or a DLL that will be ingested and used as the parser. So this is where we're doing the parser generation part. Essentially, it's going to put into the build directory a languages.so. On Windows, it's actually going to produce a .dll, but it doesn't matter the extension. This was kind of tested on Linux, and I'm running it on Windows now. So it's going to say, all right, which languages do you want to include in this binary or this library? And that's going to be parsers, treesitter, PHP. And you can include many of them in this and do multi-language processing. So if you think one file has multiple languages embedded into it, you can actually compile all of those under one language, shared object or DLL, and use that one library, right? So once you run this build, everything will be ready to go. Then you can run Lazy Bloodhound, because Lazy Bloodhound is going to essentially import this shared library or this library. So let's go into main. So I have some helper functions. One of them is going to be get PHP parser. And if we go to where get PHP parser is, it's literally just going to say call treesitter language, give it the actual language that we want to, or the library file. This is why it doesn't matter if it's .dll or .so. We'll tell it that. It will then load PHP from it. So if I did include Bash and JavaScript or whatever else, I can specify the specific language I want to load from that shared library, right? So then we generate it, we get a parser, we set the language for that parser, and then we return it. So in here, when we go back to main, the kind of flow is going to be, we'll start up, we'll go get that PHP parser, since it's the only one that we support. I have a read source file, which essentially is just going to get all of the, open that file, read all of the data from it. It's going to set it as config. Inside of config, we have this object that's sort of global in this project that contains different data. So like alerts, so if, alert number, the symbol table, all of those things. So that way I don't have to pass it around between a bunch of different functions. And then we're going to set up this tree. So PHP parser, parse, and then you give it the code that we read in from the file. We'll create this tree. We will then walk that tree. So we have tree walker. When you do tree.walk, it allows you to start walking the nodes in this tree and how they're connected. So essentially you have this syntax tree, or you think of it as an abstract syntax tree that has all of these different nodes, and we're able to traverse this. And as we enter a node, we can do certain things. As we leave a node, we can do certain things. We can delete lines. We can, change the names of variables. We can do basically whatever the heck we want doing this, but we're going to passively observe. As the parser starts walking through the code that we're analyzing, we're going to watch the entry of certain nodes, and we're going to print certain information. So the way that that is going to work is we have a lot of stuff that we don't really need in this project. So for example, look at all of these things here. So this is 500 lines of code, but it's probably half that or even less. So when I enter a binary expression, we're given a cursor that into that tree. And then if verbose is specified in the global config, then I'll print some information about that node. So let's go back here, and then now I'll run this with v for verbose. And that is why when we see all of this stuff coming out, it's when we enter a variable name or we enter a specific node type, it's going to print some information out about this. So this start point and end point, these types of things, tell us on this line, on line 26, that starting at 25, so it's 0 index, it's actually 25 plus 1, which is 26. At index or column 3, and then column 4, there's a certain node type, and that's a $sign. So this is going to be represented for a variable name token. It's going to tell you all this type of stuff, which is really great. So if I want to be alerted every time that there's a variable being assigned, I can specify which thing or expression I want to do analysis inside of and do it from there. So for example, there's one called an assignment expression. And when we enter an assignment expression, what we're going to do is I'll generate this like symbol data dictionary here, and then I'm going to apply that later on to the symbol table. So that's how we keep track at the end when we print that whole symbol table of this guy, is that as we walk this entire tree of parsed source code, we're going to look and see when there is a variable expression being assigned. And then when that happens, I'll extract the data from it and slap it into the symbol table. At the end, I'll have a symbol table with all of the assignments for us, right? So it's pretty cool. So that's done on side of this process expression. The way that I've done this is I have sort of like this statement dispatcher. The statement dispatcher is going to have a list of all of the different things that this particular parser exposes. So token comma, token arrow, PHP tag end. These are all very specific tokens to the PHP language and the PHP tree sitter parser, right? So if you were going to include bash in here, you'd have to have your own list of statement analyzers for this. That's why the debug switch has some extra information that says like unhandled. I need to get rid of this thing printing. It'll say unhandled node, right? So there is a dispatcher. There's actually no dispatcher for that node. So what I would need to do is if I wanted to handle these assignments here, I would need to add a dispatcher in for it. So when it hit that, it knows what function to call and say, I've hit this specific node, now go do something, right? Okay, so statement dispatcher, cursor, let's say we hit an include expression. We'll go to that included expression. So imagine PHP, you can include other files. So let's say we hit one of those include operations. We can then take the information of what's it including, go find that file, ingest it, and now bring it into the context of our analysis right now. Wow, that's so cool, right? So this is a really great way to not just look at one individual file, but consider the variables, expressions, everything else that happens in a global state from other pieces of the puzzle, right? So this doesn't do that. This is a really simple analyzer, but you could do it. All right, so going down a little bit more, that's it. So then we have a statement handlers list. We get the cursor type and give it a cursor, and it's basically going to go to this location. It's going to figure out what cursor type it is. So let's say it's a trait, and then it'll call process trait with the cursor. So then what will happen is it'll jump down to the def process trait, and it'll do stuff. Right now, it only does something if verbose is set, and all it does is print the line number and give you a little information about the node. But if there's some analysis I wanted to do in here, I can type up that analysis and do it right now. So where do we actually do analysis to cause the alerts? Great question myself. It's inside of process function call expression. So every time we hit a node that is going to be a function call, what we're going to do is grab some information. I'll grab the current symbol table. I don't think I actually use it right now, but you grab the line number, we'll grab the function name node and the arguments. There's two main points to this type of expression. One is what function are we calling? And then what are all the arguments or parameters being passed to those, right? So what we end up doing is we'll take a look at the arguments. So I have this function that will end up getting the arguments as like a text string and nodes, and it splits them apart, kind of does little helper type stuff. And it gives us two lists. One list is the individual arguments as text, so you just print them out and really easily. And the other one is as a node object. So as that node object comes around, or even just the strings, right? We can enumerate each one of them, and if the function name that we've collected from the node that we entered is in the list of system or exec, then we're going to go, oh, okay, let's pay attention now. And then we're going to look at all of the arguments, and we're going to say, is a $_ there? This is to account for things like $_ get or $_ request, like this guy, which is in the actual thing. So that way I don't have to worry about specific like MAC address or whatever else is used. I can just look for that. And if those two conditions meet, then I can go ahead and update my alerts. And at the end, it'll print out the total number of alerts and what the issue was, what line number and everything. So that is really it. That's all it's doing. But you might have a question. Now, what if the variable dummy is declared earlier and it's declared with request MAC address or something? We won't see that here. We're not going to alert. Well, the cool thing is we already have or can first build a symbol table that if we're using it here, it's already been declared and it's already been initialized to some value. So what we can do is we can take $dummy, go to our symbol table, figure out where it was actually declared or all the locations where it's been set so far, and then evaluate that further, right? Rewalk that node. And then we can determine that request was been used or been defined to a variable, which is now passed to this, right? So now all of a sudden it opens up just like so many more avenues for like really cool things that we can do. So I hope this was interesting for you. If you want the code, I'll put it in the description below. If you have any questions, let me know. Otherwise, happy hacking.